Good morning, students. Very good morning to all. Today, I welcome you all for today's Mechanics of Solids class. In today's class, I am explaining about stress strain curve. Okay? In today's class, I am explaining about stress strain curve. This is one of the important topic in the point of like competitive examinations or also in the point of like research point of view. uh, Topic related to stress strain curve is very important. So today I am going to discuss that particular topic. Okay. Wait for a few seconds. I will open my PowerPoint presentation. Good morning, my dear students. So I already mentioned that in today's class I am going to explain about the topic related to the stress strain curve in our subject or course mechanics of solids. The topic is related to the stress strain curve. Okay, you know that I already mentioned that the stress strain curve, okay, mainly like different parts or components in the real world would have the withstand some different external forces whenever they are in operating condition. They may be subjected to the different external forces. Okay, that will be happen entire in that particular lifetime of that particular product. Okay, so and also uh, whenever the product designers should consider some always whenever they are modeling or designing any product. Okay, they will check that there's some they will how this particular different product, whatever the design, whatever the product they designed, how it will subject to the different external forces, and how it will be affect the factor of safety. All these things will be considered. So in this point, the stress strain curve represents the behavior of material. The stress strain curve represents the behavior of the material when an external force is applied. We already mentioned that whenever the component, whatever the design product or even in working condition, the some load will, some external force will act on the component. So in that scenario, we'll use this particular engineering. There are different even stress strain curves are there, like engineering stress strain curve and true stress strain curve. Okay, and it will be differ. These whatever these stress strain curves are there. Okay, there will be for different materials, like for ductile materials, the stress strain curves will be one different type, and for materials, the stress strain curve will be different. Okay, so mainly we know that what is the stress. Okay, and we know that mathematically stress is represented by resistance force by unit area. Okay, so whenever this load is applied, or some external force or some force is applied over the body, then material, the inside molecules will resist that applied external force, and due to that it will develop some resistance, equal and opposite resistance force. You will try to oppose that applied external force. Due to that, it will develop some stress in the particular material or product. Okay, so uh, like uh, like in actually in practical scenario, okay, to draw the stress strain curve, or to uh, measure the to estimate the different properties. Okay, we'll perform some tests by using the UTM machine, ultimate tensile testing machine. Okay, UTM machine we'll use, and by that we can perform some different tensile tests, and we can perform compressive tests, and we can perform shear test also. In this particular, in this today's particular topic, okay, mainly we'll discuss what are the different zones and different points in the stress strain curve. You just observe that this particular main stress strain curve, the stress is represented on the y-axis, and the strain is represented on the x-axis. The stress is represented on the y-axis, and the strain is represented on the x-axis. So, like according to the different loading conditions, the different points were marked in the particular stress strain curve. So, when one you can observe that at the origin 0 point, the point is marked as O, and after that from origin like 0 0, the various points are marked at some different distances like point A, point B, point C, point D, and point E. This like up to like the up to like point A, so 0 to A, okay, the zone is related to the elastic behavior of nature. Like whenever you are applying some load over the material, external force over the material, then the material will subjected to some resistance force, and that due to that it will develop some stresses in the material. Then in the particular zone like 0 to A, the stress is directly proportional to the strain, and also so that particular proportional limit, like we are mentioning that the stress is directly proportional to strain up to what point. So the stress is directly proportional to strain up to the point A, and so and also beyond that, okay, if you are keep on increasing the load, okay, then the stress values keep on increasing, and at one particular point, okay, the material will subjected to the permanent deformation, okay, then it will lose the elasticity nature or elastic behavior will be lost by that particular material. So that will happen at the point B, okay, point B, that is the upper yield stress point, and point C is known as the lower yield stress point, and point D is known as the ultimate stress point, and point E is known as the fracture point. So I already mentioned that limit proportional limit mainly it is mentioned that from 0 to A. So according to Hooke's law, okay, Hooke's law, proportional limit is the limit where the stress is directly proportional to the strain. Proportional limit is the limit where the stress is directly proportional to strain. So as per this law, so up to the area, some point O to A, this particular zone, the stress is directly proportional to strain. And elastic point, like from point O to B, the nature of the material will be elastic in nature. Already mentioned that, and also sometimes mentioned that the zone is known as the elastic limit zone, that is 0, that is O to B. O to A is the proportional limit zone, and O to B is known as the elastic limit zone. So because up to the point B, the material will have the tendency to come back to gain its original position. Whenever you are applying some force over a material, external force, if it is tensile in nature, then the material will get elongated. Once you remove that load, external force, then the material molecules will come back to its original position. That we will call it as the elasticity. Okay, that will call it as the elasticity. So up to this particular point 0 to B, the zone is related to the elastic limit zone. So after that, we already mentioned that point B. So beyond the point B, the whatever that is ductile material will be started to the permanent deformation. So then it loses the elasticity nature, and then it will behaves like the plastic in nature, and it will attain the plasticity property. So plasticity is nothing but whenever like you are applying some external force for the material, then there is a change in the there is a deformation in the material. When you remove that external force for the material, then material molecules won't come back to its original position. In elasticity, the material molecule will come back to its original position, but in plasticity, the material molecules won't come back to original position. So then it is known as the plasticity. So from point B, the particular entire zone will comes under the plasticity zone. And yet we are also mentioned that there are some yield points, because after point B there is a permanent deformation. Plasticity zone is going to occur in the particular stress strain curve. So this particular point B is known as the upper yield point. So where the material required the maximum stress to initiate the plastic deformation inside the material, because it is the start like just initiation of the plasticity nature in the material, so it requires high amount of load. Okay, so it requires, so then it will attain the maximum stress in the material. That's why the stress value is increased. That point is known as the upper yield point. And after that, like you can see that the point C is known as the lower yield point. The lower yield point. So the material it will increase with a small increase in the tensile load. Here, like after, because already the material gets that plasticity material, that permanent deformation is started, then after that but just with a small increase in the load also makes the material to elongate, okay, with a smaller load also. So that's why with just increase of smaller load there is a increasing value, because you know that stress equal to load by area. Okay, whenever the stress is directly proportional to the that load value. Okay, that's why, because at point B the load value is higher, that's why you are getting higher like that particular yield stress value. After that just we are increasing the small amount of load. Okay, that's why there is a that stress values get decreased. That's why the point is known as the lower yield point. Lower yield point. And after that the point like D, it is known as ultimate tensile strength, because of after keep on increasing the like the external force over the material or load over the material. Okay, then the ultimate strength of the material will be maximum. So at point D, where because you are keep on increasing the load, then the gradually this particular stress value also get increased. So during this particular increase in the stress value, the stress value reaches the maximum stress point. So that particular point will call it as the like ultimate tensile stress point. Ultimate tensile stress point, where in the ultimate tensile point it is marked with the point D. So this particular zone where the stress is the maximum value. So after this point D, then initiation of necking starts inside the material, and once it started the initiation of the necking at that particular material, after that we were increasing the acting little load on that particular material, then at one particular stage at point E, the material fractures. The material fractures or it breaks. Material will fractures or it breaks. So that particular point we are calling it as the like fracture point or breaking point. So these are some important points or zones. Okay, you know that the zone here we marked as like from point B. Here you can see that from point B to D. Okay, one point D to D, the zone is known as the related to the strain hardening zone, because whenever like some you are keep on increasing the load inside the it will start the material get hardened. That's why that particular zone is known as the strain hardening zone, that is from point B to D. Okay, and after that because you are keep on increasing load over the material, then at one particular point, okay, that the entire load will act and there will find the entire deformation or entire load will concentrated and necking will starts from point to D till the fracture point. We can call it as the from point to D, that is maximum ultimate stress point to the point E. That particular zone will call it as the necking zone. Okay, hope I think you understand about this particular topic related to the stress strain curve.